Hey everyone, Morgan here. So in organic chemistry, page 4, we're going to talk about isomers, and this prefix iso meaning the same. So isomers are two compounds same formula, okay, different structure. So let's talk basically about a structural isomer. Butane and 2-methylpropane. Butane has 4 carbons long. There we go. 2-methylpropane is 3 carbons long with a methyl there. Now in both cases, it's the formula C4H10, but it's put together a different way. Okay? Ethyl methyl ether has 2 carbons, an oxygen, and then a carbon. But propanol has 3 carbons in a row, an OH. So we're always looking for that longest carbon chain when we're doing our names. Ethanol, 2 carbons with an OH group. Dimethyl ether, the 2 carbons are separated by the oxygen. So there's your basic idea behind structural isomers. Now sometimes the isomer can be positional in nature. 2-methylpentane, 1, 2, 3, 4, 5. And on the second carbon, we'll put another methyl group. Draw on all my hydrogens. 3-methylpentane, 2, 3, 4, 5. The methyl group goes on the third carbon. Always the same molecular formula, differences in the structure. Okay. Now, stereoisomers, there are a few different types. The geometric type, okay, is a little bit tricky. You have to understand that when you have a double bond, some things that can happen when you don't have a double bond. Single bond, it behaves differently. C2H4Br2, very straightforward. 1, 2, boom, 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 Br, Br. And this can rotate around and it's not a big deal, okay? However, when we're looking at C2H2Br2, there's a double bond. The BRs can be on the same side, or I can do a different isomer where the BRs are on opposite sides. Now this type of geometric isomer is called cis-trans. When they're on the same side, they're cis. When they're on opposite sides, they are trans. Okay. Now, going on to the next page, you can all turn over to page number 6 now. A different type of geometric isomer is called the optical isomer. And this was first basically figured out in the 1880s by Louis Pasteur, okay, with a compound called ammonium tartrate. He was able to identify that there were 2 different, distinctly different isomers. And he could tell the difference just by looking at them with a magnifying glass. So he separated them using a pair of tweezers, just looking at it under a magnifying glass. Now today, we have a slightly more advanced way of looking at it. It came about because of something called the Jean-Biot experiment. If we take plain polarized light, okay, comes in, hits a sample, and the sample rotates the light, so it comes out with a different orientation, we know that we have something that is said to be optically active. Okay? optically active isomer, which is often referred to as a chiral compound. Now, a chiral compound has a non-superimposable mirror image. Okay. Now, if you think about the compound methane, you've built models of this. You can turn this thing any direction you want and it still looks the same. But if you have a carbon that is attached to 4 different things, hydrogen, chlorine, bromine, fluorine, when you orient it different ways, you can tell that difference. Okay? That's important to know. And we're going to be building a bunch of these in labs so that you get a better feel for it. Okay, and that is our little bit about isomers. Thanks for tuning in.